Welcome back here to Air Crash Investigator, and today I would like us to have a look at a Sling crash. Now that was during solo consolidation, and well, as all, pretty tragic. Just a reminder there that I'm working closely with Seams Aircraft Auditing and Seams Training. And you'll see in the description below, there I've left how you can quickly get to them with their addresses. So let's just look. We're definitely going to look at the Sling, loss of control on the go-around, or running off the runway. So before we start with the runway, or with the history, so to say, let's just have a look here at the runway. The aircraft, they were doing circuits this way. I'm just going to clean it now. And then due to the wind, changed around, and now the circuits are going to be from this way. The pilot ran off, and eventually the aircraft ended there, and that's where the crash took place. Now, first of all, the students' last consolidation solo in the circuit, 5 successful landings on runway 20, that is landing in this direction. All right, change to runway 02. This is now runway 02 this way. All right, and the wind slightly left from the nose, and landing, there was a swing to left starting to leave the runway. We'll talk about that one. Takeoff with the left wing low and turning left. More try to avoid the trees. So in between here, there would be obstructions as he left and flying to the left, which he then clipped, and the aircraft more to the left hit the wing on the ground there first, and then the prop and engine impact next as the aircraft cartwheeled, aircraft ended upside down, aircraft burst into flames, and the student pilot was fatally injured. That is as terrible as it can be. Now, before we look at the causation possibilities, here you can see the runway, you can see where it goes off, and there you can see what was in front. Because of the heat there and takeoff, this was the result. Now let me clear that out, and let's say, all right, let's have a look at the loss of directional control during landing. As power increased to full, aircraft leg swing to left due to prop wash on the rudder. I've flown with people in a lighter aircraft, and as they open up, the aircraft swings to the left and say, you see, this aircraft is strange. It just wants to swing to the left when we open up the power. And say, it must swing to the left. That indicates there's a great amount of power coming through. Unfortunately, it's hitting the rudder on the left-hand side, swings the nose to the left, and. Pure basic aerodynamics. How do you compensate for that? Opposite rudder. When? Not when the swing is already developed to a point where it's difficult to get it. Where are you looking? Keep your eyes outside. Here I can see the runway. Keep the aircraft on the runway. With what? Differential brakes, rudder, whatever it's needed. Aileron's not going to help. Okay? Because that will just sort out drift and create other problems if you're closer to the ground. Then the pilot probably tried to correct with right rudder, but not enough. He tried to avoid bushes in the trees, using right aileron, left undercarriage, or some part of the left-hand side of the aircraft clip, and the aircraft swung more to the left and could not maintain flight speed. Because now, struggling to get away, the impact of the left wing first, the runway change could have had an effect on the student, but he has flown sufficient hours from this runway to make this possibility a slim one. So what I'm trying to say is a lot of people will say, oh, it's on the runway change, that happened. No, guys, it's not. We are leaving. Listen, the only reason that you leave a runway is because you're not looking where you are and reacting enough. Listen now, if somebody lands here and they go there, it's because they were looking inside and not outside. Inside, there's nothing to see. The moment you close the throttle till you land, and you open up the throttle, it's you and Mother Earth. Once the aircraft is straight and settled, you peep inside and you see what the speed is, and then you do the next reactions. But if you make yourself blind, the aircraft will leave your desired path due to aerodynamics and natural phenomena, such as a wind from the left. Let's see what lessons can we learn. Most light aircraft accidents happen during the landing phase. That is a super true statement, by the way, and I can show you the statistics. Landing in a crosswind condition must be trained, and it must be trained deliberately. Please, instructors out there, the technique on how to stop the drift and how to maintain the longitudinal axis aligned with the runway, that's crucial. Yeah, but we don't fly when the wind is bad. Okay, but you cannot predict the wind, what the wind is going to be after you take off. An hour later you come back and there's a wind blowing that you don't understand where it comes from. What are you going to do? So I wasn't trained for this and die. No, of course not. Use the opportunities. There are many opportunities. We should just take those opportunities. But it is training. It must be hammered in. Where do you look? Because if you look inside, you're blind outside. When you're blind outside, aerodynamics, mechanics, natural phenomena will take care of what you are not taking care of. And believe me, it's not the same outcome that we desire. Swing must never be allowed to develop. On opening up the throttle, the little one tends to swing to the left a bit, well, quite a bit. All right, 6-knot wings will do that due to the tension split. There is a thing. The aircraft tends to enter into a turn left due to slipstream. But, you know, if your attention slips, let's make a very obvious statement. You cannot fix which you do not know is wrong. How will you know it's wrong? Sorry, guys. Only your eyes. Seat of the pants. Nonsense. Don't know who. That's war stories. It's not seat of the pants. It's what's my eyes. What am I seeing? What am I seeing? Because what am I seeing is what I'm going to counter with inside the aircraft. Maintain the aircraft aligned with the runway. When picked up low wing speed, the ailerons must not be used, but rudder. We've seen that opposite brake can be used. Differential braking, directional throw when rudder is sufficient. There's a go or no go decision, and it must be well in advance. Really, in this specific case, there was sufficient time to not go until it was too late, because we were going to end up in that obstacle, and we had to go, and hope we make it. Well, sorry, hope didn't pay off. Obstacles in the close vicinity of the runway, I also think that those things must be cleared. Really? Really? When you look at your runways and there's stuff like that, yeah, but that's far from the runway. Okay, who are you training? What is far? That is too close, I would reckon. If there's no obstacle, that might just give you that gap to recover. Nothing I've said here is to point a finger. It's to point us in a direction to understand what is required so that we can give ourselves a better chance. Well, that's it for me now. See you in the next one.